Okay guys, here's your helpful hint video for the 2007 4B question. It's no calculator. Let's read it and we'll kind of figure out what's going on. So this whole beginning here is almost completely useless to us for what we're going to ultimately try to accomplish here, but we'll still read it. It says a particle moves along the x-axis with position at time t given by this. This piece here is the only part that's really just not useless to us. But I mean, basically what they're saying is that a particle is moving along the x-axis, and you can find out where it's located at any given time by plugging in some value for time, and it will tell you where it's located on the x-axis. That's what this equation does. But like I said, that's not really horribly useful for what this question in Part B is asking us to do. In Part B, it's really just a really intense exercise in applying the derivative rules and also in applying algebraic rules to solve a problem. So it's really not anything having to do with this concept up here of a particle moving. But let's read it. It says to find the value of the constant a. So I want to figure out what this value is here. Find the value of the constant a for which x of t satisfies this equation. This is a really weird question, okay? So this helpful hint video is going to be a little bit different than most. Instead of me just giving you a few hints and then letting you try it again on your own, what I'm going to do is I'm going to tell you what to do at each step. I'm going to encourage you guys to pause the video and let you try each step on your own and then unpause it, and then you can check your work as we go. So first thing we want to do is notice that it's a times x double prime and then plus x prime plus x. Okay, well, we already have x, so that's nice. It's right here. All right, but we also need to know what is x prime. So we need to find the derivative of this. So I'm going to say go ahead and pause the video and see if you guys can find the derivative of this. Now, think in mind, think about what we've learned. We know how to find the derivative of e with a chain rule, right? And we also know how to find the derivative of sine, and notice this is a product. So see if you can get it. Pause the video and give it a shot. Okay, so I'm going to go ahead and work it out now. So here's our x, right? We have e to the negative t times sine of t. We have two parts. We have e to the negative t and we have sine of t. I'll call this a and this b, right? This is a product rule. So we're going to have a b plus a b. Oops. And on the first set, we'll do the derivative of the first one. On the second set, we'll do the derivative of the second one. Okay? All right, so here we go. So a prime. So I want to find the derivative of e to the negative t. Well, we do the derivative of, notice this is a chain rule here. Here's my inside function. The outside is the e function there. So it's the e power. So when you find the derivative of e, it's just the same as it always is, right? But we need to multiply that by the derivative of the inside. So what's the derivative of negative t? It's negative 1. Now, I'm going to write negative 1 here, but if you don't mind, I'm going to actually erase that right now, because I know, since I've already worked this problem out, I know that that's going to get messy after a while. And I'm just going to say negative 1 times e is negative e. I'm going to put that there now, okay? But if you got that, you're good. And then here, we're going to go ahead and just put the b function, right? It's sine of t. Next, we have a, which is going to stay unchanged. And then we have b prime, the derivative of sine is cosine. There's your first derivative, right? So now we know x of t because it's given to us. Now we know x prime of t because we just figured that out. Now we need x double prime of t. That means we need to take the derivative of this again. And this is where it gets kind of a little bit overwhelming, because we have to find the second derivative, I need to find the derivative of this thing now. And the reason that's overwhelming is because there's two product rules here. And so what I'm going to do is I'm going to set it up for you, then I'm going to ask you guys to pause the video and see if you can get it. So here's the setup. We have one product rule right here now, right? If I want to find the second derivative, I need to take the derivative of this. And that's a product, right? So I need to find a product there. We also have another product rule right here. So if I want to find the second derivative of this, I need to find the derivative of this, and both of those are product rules. Well, let's go ahead and get the setup going here. So if I want to find the second derivative of x, then I need to find the derivative of this, and that's a product rule. So we're going to have a, b plus a, b, right? But then we have plus, and then it's another whole different product rule over here. So it's another a, b plus a, b. So we have 4 blanks we need to find. Okay? So before I ask you guys to pause and work on it on your own, I'll just reiterate. You need to do the product rule on this, fill in these blanks. You need to do the product rule on this, fill in these blanks. Go for it. See how you do. Okay, so I'm going to relabel these a little bit. Not much different, right? I'm going to call this A now. I'll call this B. It's going to be A, B, prime the A, prime the B. So here we go. So A prime. Well, so if I take the derivative of this, we have an outside function here, which is negative E, right? And then we have the inside function, which is negative t. So we do the derivative of the outside. So whenever you do that, the outside, the negative 1 is going to stay, right? And then we have, with e functions, it's always just the same. So there's that. But now we need to multiply it by the derivative of the inside. So the derivative of negative t is negative 1 again, right? So times negative 1. But like I did last time, I don't really want to put the negative 1 here. I just want to multiply it to the front now. So a negative 1 times a negative 1 actually turns out to be a positive. So this negative cancels that negative, and we're good. Let's do this one now. Sine of t. B doesn't change, right? We're just going to put sine of t. Next, we do a without changing it. And then we do b prime. The derivative of sine is cosine. Okay? Now we come over here and we're going to do the other product rule. So I'm going to call this first one A, the second one over here B. So it's going to be AB, derivative of the A, derivative of the B. So there we go. Find the derivative of e to the negative t. We did that earlier and we found out that it was negative e to the negative t. Derivative of the outside is the e, derivative of the inside gives us a negative. The b stays the same. A stays the same. B prime. The derivative of cosine is negative sine, right? But I don't like having the negative in there. It makes it look like a minus, and it's not. So what I'm going to do is I'm going to take that minus, I'm going to multiply it to the very front, which is going to change it from a plus into a minus there, okay? Okay, so now that we have all that lovely stuff, I think I'm going to go ahead and I'm going to try to write this stuff a little bit more clean here. But we have almost everything we need to begin doing the problem here. We have x double prime, we have x prime, we have x, and we're looking for this a value. Let's not forget what we're really trying to do. And by adding, so here's what it's saying basically. If you take x double prime and you multiply it by a, and then add to that x prime and x, you should get 0. So the question is, what value of a will accomplish that, right? So basically what I'm going to do is I'm going to take my answer that that we have for x. I'm going to take the answer that we have for x prime and the answer we have for x double prime. I'm going to add them all together after I multiply x double prime by a. All right? Now, before we do that, though, I just remember there's something else we want to do. We want to be able to combine some like terms here. There actually are. It's really ugly, but look here. See, I've got a e to the negative t with a sine t. Okay? Well, here's another one over here. Okay, I've got a positive e to the negative t sine t and a negative e to the negative t sine t. Okay? Well, they're exactly the same. It's just that this one up in the front here is positive, this one's negative, so guess what happens? They go away. That's pretty sweet, right? Now take a look here. Here we've got a negative e to the negative t cosine t, and here we've got another negative e negative t cosine t. What would happen if we combine those? Why don't you guys pause the video and see what you would get if you combined those together. All right, well, here's what I would get. So notice that they're not opposite signs this time, so they don't cancel. It's not like this one, which was a positive, this one, which was a negative, and they canceled. In this case, they're both negatives. So what happens when you combine a negative with a negative and you're adding them up? Well, it just becomes -2. So putting this one together with this one gives us -2 e to the negative t cosine t. And that's all that we have left for x double prime of t, because x double prime of t had these 4 things, right? Well, 2 of them canceled and the other 2 combined together. So there's a nice simple expression for x double prime. So we don't really need this big nasty looking thing anymore because we simplified it. So I'm going to erase all this stuff now. See, now we got past the calculus part. We're all done with the calculus part. The calculus part was finding that derivative. Now we're on the algebra part, which is really not any less difficult. It's really an exercise in just knowing how to work through the numbers here. So I want to rewrite this too underneath really quick. So we have x prime of t. Now nothing over here simplifies because we have a negative e negative t sine t, and then we have a e to the negative t cosine t, and those aren't like terms, so we can't really combine those at all. But there's that. Okay, so here's where things get a little bit interesting. I want to take this expression here and I want to replace these x primes and x's with what they are. So here we go. Let's write it out first. A x double prime of t plus x prime of t plus x of t equals 0. So I want you guys to do this. I want you guys to replace x double prime with this thing. I want you guys to replace x prime with this thing. And then I want you guys to replace x of t with the original problem there. Okay? So go ahead and do that. And pause the video. And here's what we should have got. So a, and in brackets here I'm going to have -2 e negative t cosine t plus x prime. I'm going to have this whole thing here and then plus x of t, which is up here. We have e to the negative t sine t, and all this equals 0, right? Now, I want you guys to see if you can find the like terms, because actually in this expression here, there are 2 things that will cancel each other out right now. I want you guys to see if you can find it and cancel those out. Okay. All right, so I'm going to drop the brackets here. We don't really need them anymore. Okay, so it's hard to find them, but here they are. We have a negative e sine t and a positive e sine t, and they cancel each other out, right? So now let's go ahead and simplify some more. So now I've got this, I'm going to switch the a and the -2 here so it looks more algebraic. We don't usually put the variables in front of the constants like that, right? So there's the first term. And then we have the second term. Okay, now, here's the next step. I want you guys to pause the video and factor out what this term and this term have in common. Okay? Go ahead and pause the video and give that a try. Factor out what they have in common. Okay, so what they have in common is they both have an e to the negative t and a cosine, right? I'll highlight them for you. So we have e to the negative t cosine t, right? And this term over here also has an e to the negative t cosine t. We're going to factor out what they have in common. So here's what they have in common, e to the negative t cosine t. And what is left, if I were to factor that out, is if I divide this yellow part out of here, I'll just be left with the negative 2a. And if you divide the yellow part out of here, well, anything divided by itself leaves 1. Okay? Well, I want to solve for a. Remember, that's my ultimate goal here. So this times this equals 0, which means that one of these equals 0. And if I want to solve for a, I want to use this one. So set this equal to 0 and solve, and you've got your answer. And I'm sure you guys can handle it from there. But set that equals 0 and solve, and you've got your value for a. So that's a pretty crazy problem, but it's a great intense application of the product rule and also some algebraic properties, which, you know, we'll be using those algebraic properties of factoring and combining throughout the year. So it's a great exercise, even though it's probably very overwhelming for you guys at this point. I understand that. But hopefully we'll get you a little bit more used to it as time goes on. So there you guys have it. Let's go ahead and move on to our next helpful hint video. So this is your helpful hint video for 2017 6 A, B, and C, due next week on Tuesday. This is a cool question. I really like this one. I think this is one you guys really want to understand. I just think it's a great question. It hits up a lot of cool objectives that are very common in a Calc AB AP. So let's go and take a look at it. They've given us a table. This table represents the values of a function named g and also its derivatives at the same points. Then it gives us a graph of another function, which is the graph of h. And then finally, they give us another function. So we're dealing with 3 functions here. And the last one they give us is in the form of an equation. So we've got a table of one function, a graph of another, and an equation of a third. So they tell us that it's differentiable. That's something that we don't need to worry about just yet. And then it tells us here that h is a function whose graph has line segments. The reason why that's important is because if these are straight lines, that means that, you know, they're linear functions, which we can assume they have the same slope all the way through. But I think we can tell just by looking. For now, that's okay. Anyway, so that's what they give us. Now let's go ahead and jump into the actual problem here. Part A tells us find the slope of the line tangent to the graph of f at x equals pi. So I'm not using this or this for part A. I'm just focusing on f. They want to know what is the slope of the line tangent to the graph of f at x equals pi. Well, how do you do that? Well, you're going to find f prime, and then you're going to plug in pi. So that's it. So you're going to have a chain rule here, and you're going to have a chain rule here. Okay? So that one's pretty straightforward. I think I'm going to let you guys handle it from there. But basically, you just have to find the derivative of this, plug in the pi, and you've got your slope of the line of f at that point. Let's go ahead and take a look at part B. Okay, so this one's cool. It's giving us a new function now, which is going to be called k, and k is equal to h of f of x. They want us to find k prime of pi. Okay, well, here's what I'm going to ask you guys to do. Go ahead and pause the video and see if you guys can find k prime. K prime of x would be equal to what? It's a chain rule. There's your hint. Go ahead and give it a shot. So derivative of the outside, right? Don't change the inside. Multiplied by the derivative of the inside. Okay? All right, now we want to plug in pi, right? So plug your pi in. Okay, so my last hint to you for part B is this. They're asking you to plug in pi here, which is f prime of pi. Well, hint, hint, you did that already in part A. They do that a lot of times in these FRQs so the problems don't take so long. So you've already got the answer to this piece here from part A. But this piece here, it's asking you to find h prime of something. Well, eventually somewhere along the way, you're going to have to come up here and find what is h prime. Well, h prime is the slope. So like, for instance, let's say you come up with h prime of -1, right? Well, here's -1. Well, what's h prime of -1? That's the slope at that point. So what's the slope of this line? Well, the slope of that line is down 2 over 2, right? So that would be a slope of -2 over 2, which is -1. So basically, h prime just means what's the slope of that line at that point, okay? So after you plug your pi in here, find out what f is at that point. That's going to tell you where to look on your h graph to find your point. So I'll let you guys do that as well. So that's the end of part B. Let's take a look at part C. On part C, we're being asked to do the same thing all over again. Just find the derivative and plug a number in, right? But they're giving us a new function. This new function is a product of two other functions. So to find m prime, you're going to have to do the product rule. But notice that g is also a chain rule there. So you've got an inside and an outside there. So you're going to do product rule with chain rule, and you're going to plug in 2. And in this case, since you're using the g function, you're going to be using the table. Okay. You're also using the h function, which means you're also using the graph. So, but there's no f on this one. But I'll leave you guys with that one and see how you do. All right, let's move on to our last FRQ for this particular weekend. We're on 2014 5C. Once again, no calculator. Let's read it and understand it. So it tells us we have these two functions, f and g, which are twice differentiable. That just means you can find their derivative twice. That's kind of irrelevant to us for right now. They're defined for all real numbers x. We have f, f prime, g, g prime for all values of x. So they basically just have, it's a table problem. So right here, f, the value of f when x equals -2 is 12. And for anything between -2 and -1, the y values are positive. Remember, f of x is the y value, right? So, and when x equals -1, the y value is 8. But for anything between -1 and 1, the y values of f are all positive, etc. Okay? Then they give us the same information for its derivative at those values. So now when a derivative is negative, remember that means that a line is decreasing, right? And whenever it's positive, that means the line is increasing. They do the same thing for g prime. Okay? Let's go ahead and take a look at part C, though. I don't know how much of that is going to be necessary for the problem. Let's read it. It says the function h. So they're giving us a new function. The function h is defined by ln of f of x. Find h prime of 3. Show the computations that lead to your answer. Well, we're just kind of keep getting the same question over and over again here, and that's good. It's good practice. So hopefully you guys are starting to get a little bit used to this. So you need to find the derivative of h, which as you can see here is a chain rule, and then plug in 3. That's it. So that's pretty straightforward. I think you guys got it. Find the derivative of h, plug in 3, and that should get you your answer. Okay? And I'll leave you guys with that and bid you have a good weekend.